Hello everybody.
How's that? Good. So my name's Alex Moon. I work for Tangent Labs in London. I'm going to do a talk just on very elementary concurrency. It's kind of the new hot thing. We're doing a lot more sort of ripping the guts out of big fat Django apps and putting them into back-end services. I don't know how relevant this is going to be. How many people in the audience have actually done any concurrent programming in a concurrent language, with concurrent practices? Okay, a few, good. More importantly, how many people are using Django alongside some kind of queue with lots of different processes doing processing asynchronously? Right, a lot more. Okay. So, first of all, who is concurrency when she's at home? It's not parallel, it's not distributed, though it's not necessarily not parallel or not distributed. In fact, it's suited to both of these things, but at its base, it's a single process on a single box, and it's threaded, basically just context switching between threads, almost as though they were different processes, but with a certain shared memory. Very cool, it's very powerful, for the same sort of reasons that running lots of different processes side by side is very powerful. However, it comes with its own set of problems, which it's worth being aware of as developers who might start trying to write this kind of programs. In particular, there are 3 requirements for any current program. For some of you, this is going to be terribly elementary. For some of you, this is going to be completely head in the air. First of all, mutual exclusion, roughly speaking, data integrity between the threads. Freedom from deadlock, roughly speaking, the program shouldn't ever hang. And freedom from starvation, which roughly speaking is all inputs are processed the same way that they are when you iterate over them. The way to do this, the way to ensure these things, because you have things running side by side, you can't just step through it the way you can step through a serial program. So debugging is no longer an option. You have to prove these programs theoretically. The way you do this is by using a protocol. Protocol literally is just when more than one thread comes to the same piece of logic, the threads need to know which of them can run at any one time, wherever they're writing shared memory. This is part of why functional programming is really good for concurrency, but we're all used to Python. So it should be efficient when there's only one process coming in. It should know straight away that it can run. It should be when there's lots of processes trying to run, lots of threads trying to run, minimal resource consumption. It shouldn't be using lots of processor or memory. Most importantly of all, it should be simple. It should be a one-liner if possible, a separate library which everyone can just import whatever. So let's dive right in. I'm going to write in Go because it's a very sexy language. If you haven't tried it yet, please, I can recommend it. C-like, curly braces, but with some added goodness, in particular this guy, which says start a new thread, and this guy, which is basically just a buffer between threads. You can pass it from thread to thread, and when you write to it, it'll just pass it back to whatever thread has it in scope. Very handy. We're going to take a long stream of numbers, and we're going to store means and standard deviations for these as they come in. The critical section, obviously, is we're going to update them based on the old means. So if the old mean is wrong, or if the old standard deviation is wrong, then we get wrong answer down. Right. First attempt, just throw them all at the code. So the code looks roughly like this. It's ugly. I'm not a Go programmer. We basically generate a ton of words, we give them a random score, and we pass them back through a channel. Now, we are literally going to, for each of these scores as they come in, just flying at us forever. We're going to start a new thread, and we're going to do new Clotted, which is just, it's very basic. This is how you work out a new mean based on an old mean, a new standard deviation based on an old standard deviation. And we're going to do these all side by side, and then we're going to write them to a big long list of these terms. So let's give it a go. Basically, this is all available on GitHub. The sources are on the slides. Go, run, first attempt. So the first thing that you notice, the synchronous, this is just a standard serial, whatever. I'm just out of time. Okay. I'm going to jump off, but you can see the rest of the talk online. I'm Alex Moon. Thank you for listening.
On testing.
Thank you. I need to start with an admission. I'm Peter, and I'm a testaholic. That means that I spend a lot of time writing tests and thinking about how to write better tests. And polytesting is the latest proof of concept project that came out from a lot of my frustrations that we experienced in our company. And I'm just going to run through it in 5 minutes, hopefully. So, who here is familiar with the test pyramid? Just show of hands. Some people. Essentially, it says that write a lot of low-level unit tests and then make sure your components are integrated, and then just write a few integration tests to make sure that they play nice together. Except some people can do that, and a lot of respect to them, but most of the time what happens is that we have a bunch of green tests, all the components are working, except when you deploy to production, it's completely broken because of unexpected interactions. The alternative is that you do a full stack testing, Selenium, Apache, everything else, except then it's impossibly slow, it's brittle, and it takes forever to run. And when something takes forever to run, it's not going to be run. So the idea is that let's give the same set of tests, and let's run them in different contexts. So the developers can run all the fast tests in memory against the business logic, and then later on the build server we can actually let it run all the Selenium tests, and then we have the best of both worlds, fast feedback and thorough feedback. Now this kind of polymorphic approach is not new to testing, because a lot of people run their same test against different databases. A lot of people run their Selenium tests against different browsers, when you take one set of tests and just run it in completely different configurations. Not to mention talks, but I'm not going there. So essentially what we want to do is create an abstraction and describe our test the way our users would do. In, like, let's say if you have a Kanban board style application, that if we have a board with some initial state, then I can move a task from one person and state to another person with another state, and then I just want to assert it. The important thing is that the test itself just describes the test and specifies the API. It doesn't contain the implementation. The same way that the Chrome and the Firefox drivers are different. Then we can go on and write the basic API for our business logic, where we have some kind of a board objects, whether it's a model or whatever, doesn't matter, and then we say move. Then, if that passes, we can write something with the Django test client, where we set up the URLs and then we make like some posts, and if the post doesn't give you the expected redirect, we raise an exception. And when you get to the UI part in Selenium, you can just go and do a drag and drop event the same way your user would do it. The benefit is that QA can write your Selenium test because they are so much better at it than I will ever be. But we are using the same set of specifications across all departments and all tests. Just gonna run through the inspirations. So anybody familiar with BDD is going to recognize the kind of abstraction. Earlier before we talked about, some of the presenters talked about the ubiquitous language and BDD and how it helps communication. If you're familiar with the hexagonal architecture, then it might be familiar, as well as the page object pattern, if anyone heard of that. The current status of the project is that I've got a 95% done project. I need some JavaScript problems needs fixing, and then I'm planning to write it up. And eventually, I hope there's going to be some library or framework coming out of it, and it can be found on GitHub. But for the time being, if you're interested in these kinds of things, come and talk to me while we are on the island, or just email to me at hello.joaldesp.edu. And just to demonstrate that it actually works, let me just run it, and thank you for listening.
On Jungle Village.
everyone. I'm here at another Django conference, which will be it's the first conference with the, well, not really the first one, but let's say it's the first one this year. So will be in Orvieto, which is a nice town near Rome, which is 1 hour from Rome by train, I guess. I'm not sure. And will be in this nice palace, really beautiful. And it will be like in June, from 13 to 15 June. And we already have the tickets available, and they are really cheap. They start from 60 euros per person, and then yes, you can already find from the website, which is this one, DjangoVillage.it, and you can follow us on Twitter. And if you have questions, please find me. I will be here. Thank you.
We now have Nathan Dutoit, who is going to tell us about building a 12-factor Django app.
Hi everyone. So to start, can I have a show of hands who know the 12-factor app? That's pretty good. For those that don't know, it's available at 12factor.net. And basically it's a set of methodologies, 12 of them, to build web apps, software as a service apps. And in software engineering, we don't get a lot of defaults and constraints that are applicable to everyone. And standards don't really exist. So this is something close to a standard. And basically it's a set of methodologies and good practices that will help you not fall into the same pitfalls that a lot of people have fallen into. So we don't have time to go over all the 12 factors of them. And in particular, I want to go over a few of the factors and how we can apply them in Django. So the first of them that we're going to consider is config. And basically, the gist of it is to store the config in an environment. And we've all heard that config is a bit of a settings is a bit complicated in Django. So what can we do about it? So first of all, split your config files. And you might have already done that. There's multiple ways to do that. Just do a Google search, you'll find many ideas on how to do that. The key that I would like you to follow is don't split one for every single environment that you can possibly imagine. If you have production and staging and a bunch of test environments, don't create one setting file for each of them. Create one setting file for each class of environment. Maybe one for local development where debug is true, but then things for production, stick to one production file that you apply to staging and production, because staging and production should behave the same. And for the things that are different between your different environments, such as staging, production, variables are not defined inside of your code, because that would just defy the purpose. Those environment variables should live on the specific environment. So on your production server, you should have a set of environments variables defined. So it's a bit tricky to keep track of these environment variables. Like if you don't use source control, you're going to think, well, how do I keep track of them? How do I recreate a new server from scratch? There's a tool called Enter. It's built in Python. There's an equivalent also built in Unix, but the Python equivalent works really well for Python projects. And it basically allows you to define a single directory in which you define a bunch of files. Each file is going to be considered an environment variable. So if you have a file called foo and the content is bar, you're going to get an environment variable foo with the value bar. And the way you run it, you simply run enter with a path to the environment directory, and then your Django executable. And once you have that, those environment variables will be available inside of your app. And then in your settings, you can start using those environment variables. And that will take care of this problem of, instead of having a massive load of config files, you can have a couple of them and then still have multiple environments that you can support. The second one we're going to look at is dependencies. And basically what the factor says is that we should explicitly declare and isolate dependencies. So to do that, you use requirement files, obviously. You use virtual envs. Something you shouldn't do is use a single virtual env on your production servers. and update it, because that will prevent you from being able to roll back. So you should have a virtual env. If it doesn't change, it's fine to reuse it. But if the virtual env is going to change, then you should create maybe a new one and reinstall your packages. There's different ways to go around the slowness of that, and if you want, we can talk about it later. The other thing you should do is package and version your internal apps. Consider them like external apps that you would install, and have the same diligence about them. And to do that, you want to use your own PyPI server. There's different options out there, such as local shop and DevPI. And finally, one more thing that we're going to look at is the fifth factor, build, release, and run, where those should be separate steps. Strictly separate the build and the run stage. So to do that, what do we build? You might think there's not much to build, we're not compiling stuff. But you're still building static assets. You could build your virtual env in advance so that it doesn't have to be done during deploy. And that will allow you to do fast releases, where a release will just be to push some code and use a virtual env that's been already built. And it will allow you specifically to be able to roll back. If you use Symlinks, you will be able to do a quick rollback in production. And another thing you want to do is separate your code deploy from your config deploys. So the config we mentioned before, you want to be able to do that separately from doing a code deploy. So this is just a couple of things that you can do to follow 12-factor app. You're welcome to ask me questions later on. It's very interesting to see how you can do that. Thank you.
We now have Thibaut, who is going to explain JavaScript like if we were 5.
Okay. Hi everyone. My name is Thibaut. I'm French, not as French as Bruno Bord, but still. And I'm going to talk about JavaScript for Python developers because someone has to. We French people, we like Python because we are romantic people. And when you want to seduce, a man, you can't just read Python because Python is like poetry, it's like Baudelaire. Look at that, it's very clear, very elegant, okay? Add a glass of wine and a bit of water, and there you have it, perfect. Romantic ambience. And then here is the JavaScript equivalent, and you're not gonna seduce anyone with that. And if you do, honestly, good luck with that. So, if you're like most Python developers, when you see JavaScript from time to time, you're like, ugh. Yeah. The problem is like we're developers and where JavaScript is pretty unavoidable today. So we're going to talk about a few differences, and we're going to try to bring some love for JavaScript. So the first key difference between Python and JavaScript is how do you create objects. Python is very French. You have to be very polite. When you want to create an object, you have to ask for permission first. So you define a class, and then you use that class to create an object. Okay. With JavaScript, not so much. You need an object, just create the object. Okay. So you don't have to mess with the classes. You just create objects. Okay. That was easy. But where is my class? You can ask, because classes are cool, we like classes. And the fact is, there are no classes in JavaScript. There is no such concept as a class in JavaScript. And what are we going to do? Because what is a class for? Classes are very useful for creating objects, for sharing code between objects, and for structuring your code and your application. So let's look how we can do that with JavaScript. There is a problem with this example. You may notice that I'm creating a user property, a user object, and that user has a toString property. What is a method? ToString is a method, okay? And the problem is every single object that I create using this function has a copy of the method, has a copy of the toString. So every object has a toString property which contains the complete code. So that's bad. So how can we share some code between related objects? We are going to use something that is completely magic. We are going to use prototypes. We are going to use something that is a prototype. When you every JavaScript object has a hidden magic link to another object property that is called prototype. Prototype is just an object like any other else. And there is a syntax in JavaScript that you can use to create objects that really looks like a class, but it's not a class. It's just a function that is used to create objects that you call with the keyword, the new keyword that you can see behind. And look at that, it's very cute. JavaScript is so desperate for love that it's trying to disguise itself into a class-oriented language. And there are no classes, but good try. And what does a new keyword does is that it is going to link the object it creates with the prototype property of the function that creates the object. So it looks a bit complicated, but you can share some code by adding it to the prototype property of the constructor. Okay? And when JavaScript does not find a property in an object, it will gonna find it in the linked property. So by using this syntax, you can share code between objects without comparing it to every object. And if I still have 1 minute, okay, I could have told you about models, but that will be for next time on the next slide. Thank you very much.
Embiez is going to tell us about live demos.
Thank you. So I was under the impression that there would be a mic here so I could type in both hands, but you know what, I'm just going to deal with it. Here's where my single hand typing is going to come in handy. You're going to watch how fast I can type with this single hand. So anyone here not heard of BPython at all? Okay, you're in for a treat. Okay, BPython is a fancy REPL, which means it's just like Python.
Whoa, that's fast.
Yes. And then if you install BPython, it's just a matter of just install BPython, and it'll install BPython. And I'm going to show you the feature of BPython that makes it fancy and awesome. Let's clear the screen. Start BPython. It's just like how you would start Python. Just type BPython and then it starts up. Here's where the magic starts. As I start typing, it starts to automatically recommend suggestions for me. Let's import a module. As I start typing, again, it starts recommending. I can tab and cycle through the different options. Let's pick time. Let's see what are the different functions that are available. So it looks like if you are a beginner, doing a dot on a module automatically brings up all the functions that are available for you. Let's pick one of those functions, like time, and let's see what's the documentation has to say about that. That's a little bit messed up because of the resolution and stuff. Let's just close that and let's look at a different example. Let's do a little bit more complicated one called collections. And let me choose the counter. Now counter, again, I'm going to do a dot and look at all the methods that are available for me. Pick one that looks interesting. Let's do most common. Again, type it correctly. Sorry, typing with a single hand. So if you are opening a bracket, right away the documentation comes up. Now that is awesome. That kind of makes the deal for me in BPython. Okay, if I want to, if I read this and I go like, oh, this looks interesting, I wonder how it is implemented, all you have to do is press F2, and it shows the source code. It pulls it directly from the standard library, and you can actually take a look at it. Let's quit out of that, and it's not just for your standard library methods. I'm going to create a method on the fly. So let's create one. I'm going to type really fast. Okay. Sorry about that. Okay, let's return x, y, and let's get started. So as I start typing, even though it's a method that I created on the fly, it auto-completes. 4, 5, and now I do p.out. I don't have dot strings, so nothing comes out. Oh, I forgot to put self. So if you are on Python, you would have to retype the whole class. But in BPython, I can just hit Control-R, which rewinds, which takes me back in time. And return self.x and self.y. So anyway, if I do p.out, I actually get the answer out. So that's BPython. Anyone else impressed by BPython? Woohoo! Yay! Actually believe that I typed the whole thing? No, I did not. So this was actually a recorded demo, and it allows me to replay the demo using simulated keystrokes. And you saw that it actually captured pop-ups that happen in the screen. You can go into Vim. I'm going to show you how it's done. So it's a software called Play It Against Sam. It's an open source Python module. You just do pip install Play It Against Sam, and you use it. So I have it installed, and Pious Record Demo 1. I'm going to record another demo live. I can type whatever I want, and it automatically records them and puts it into the Dem1 that I just created, the Dem1 file. On 1, 2, echo, hello, sleep, and done. So you may have noticed that I'm actually recording Pious Record inside of a Pious Record. So it's like, anyway, it's nested. The point I'm trying to make here is, let's finish that. I can actually open Vim. I can type whatever I want inside Vim. That is also getting captured. So it's as long as it's inside a terminal, it'll totally work. Okay, I'm done. That's why there's gibberish there. So the way I replay that is, now I can type whatever I want. And as soon as I hit enter, this is exactly what we just recorded just a minute ago that I showed you this. I think I'm out of time, so I will leave you with that. So the name of the program is called Play It Against Sam, and I just keep typing. I will say just one thing before I leave. There is a couple of options called auto waypoint and auto type, which I don't even have to have done the whole typing. It actually does it for me. There it is.
We now have Embiez, who's going to tell us about hotbots and real time.
So I'm going to try to describe what.me, and can I have a show of hand of who know what me is? A few hands in the audience. So it's an IRC logger that we mainly built for us at Lincoln Loop, and then a friend of us started to ask us if they can also, or if we can also log their channel, and then a friend of this find started to ask us if they can log the channel, and we right now have about 150 channels logged, and many of the Django channel all over the place are logged. And actually, while building this, we went through few iterations, and we find out that building real time is kind of hard. And the guy that was on stage before was trying to talk about threads, coroutine, and all this, and we went through that process of learning this lesson, and hopefully I will be able to show you all my slides. So I'm going to try to describe how all this is working, and I will start by the top where it's written web. This is a Django application which is actually having a few models. The one that are interested is the network, which would be something like Freenode or Mozilla channel, because we are also logging Rust channel, and there is a few others that we have. And we have also something which is called chatbot, which is the nickname of the bot, which will be like someone joining on IRC, which is connecting to many channels. It's someone that loves IRC, and he has a funny name, and he's joining 150 channels. And then we have the channels themselves, where we are associated log and storing all this into Postgres, and it's fantastic. We are super happy. It's great. And we also have the guy here, which is a Django application. It's eating everything coming from IRC. He's joining 150 channels and reading the line, and we are throwing everything into a Redis queue. The line are in that Redis queue and are built by plugins. The plugin at this point are Python application that read from this Redis queue and do what they have to do. So we will have a plugin called Brain, which do what a brain can do. It remembers things, and we are throwing this into another Redis database. And we have one which is a bit special, because this one has access to the database. And when the line came in, you read the line, do things, and store it into Postgres. This is about half of the story. We are logging the channels, and this is captured forever. The next thing is, you want to display it to the user, because I was going to ask us to log their channels so they can read what happened when they were not online. So we have a fancy web application, which is Django, which is displaying this, and you see the channel. And very soon, this is great, and you can look at IRC on your mobile phone, and it's fantastic. But every time you want to get what's new in the discussion, you were in the need of reloading the page. We say, must have something better. So we started to play around, and it was a problem that we were already facing with another product that we are working on, which is called Ginger. And we decided to go this time with an event source endpoint. So event source is, think about it like a long polling HTTP connection. And so what we are doing is, as we are saving every line into the database, we have a signal that also sends them into a Redis channel. And we have a very small application which listens to this channel and listens to the users that are connected and dispatch the lines that the user is interested in and displays them in the interface. So this is all good and nice, and now you're asking, how do you do the private channel and the connection? And I just listen to any random channels. And this is where it gets a bit interesting. I have 30 seconds to tell you this. So the user gets into the web interface, and the web interface, what it's doing when it actually gets into this channel, we do the Django authentication. And once the user is validated, we put a token into, again, Redis, with the list of channels this guy can join. And at the same time, when this web page display gets passed and JavaScript gets evaluated, we read this, we go to the channel with the browser, ask the event source endpoint, which is in Go, and he reads the list of channels, he sees this guy is authorized, and access the channel, and actually get the information. Thank you very much, and this is about CONCURRENCY.